So good morning everyone and welcome back to the class on smart materials and structures. So if we go back to our previous session, what we were dealing up, can anyone let me know in the last class what did we dealt about? Quickly. What we were dealing in the last class? Sandesh?
Yes, ma'am.
What we were dealing in the last class?
Cantilever beam. Vibra-
Huh?
Vibration control of cantilever beam.
Yeah,
Yes.
we were dealing with vibration control for cantilever beam, and also we dealt about the multiplex embedded actuators. So
Yes,
what
ma'am.
is the need to use the multiplexing embedded when a single one-dimensional cantilever beam was enough to get the required test configurations? So we dealt, there were some disadvantages associated with the vibration control of particular cantilever beam, and hence to overcome and to get the enhancement in the results, we actually opted for multiplexing embedded type of actuators. So here we took related to what we say the nickel titanium based actuators, and we analyzed how helpful and useful a multiplexing actuator will suit to get the enhanced frequency at the lower level. Okay, so multiplexing approach helped us to get the concept of the first mode and the second mode of frequency with respect to the lower frequency range. So also we dealt about some other aspects related to multiplexing. Yeah, we dealt about the ratio time to that of the pulse length. So how the excitation results in a short duty cycle and how the variation of it comes into picture, and we studied related to that. And again, the entire process, since you have the 4 actuators here, it starts with the 1, second, third, fourth, and again it continues back. So this entire cycle we studied, and we switched on the process, and we were able to calculate it needs less time to get the response, and they were getting a large period of time to get cooling. But by using multiplexing embedded nickel titanium based actuators, even the amount of cooling time was being reduced. So major drawback in the previous vibratory control was that the cooling time was much more, and that was supposed to be compressed, yeah, condensed. So to reduce the amount of cooling time, we opted for adding the actuators parallelly. So based on this, we have dealt already how we overcome in reducing the cooling time with response to the first frequency mode. So all these has been done already. So I just briefed out. So from today, we are supposed to start up with the second part of our module 2, which is related to magneto and electrorheological fluids. So about this MR and ER fluids, we have discussed a little bit in our first module when we were dealing up with the classification of the smart materials. Can anyone let me know what do you mean by magnetorheological fluid or electrorheological fluid? Because we dealt this related to our classification part. Anyone can put some points on this? What do you mean by magnetorheological fluid? Anyone in the class, please? The answer is there in the question only. What is magnetic rheological fluid? We had dealt related to this in our module 1. Can you remember? Sandesh,
Yes.
yeah, what do you mean by magnetorheological fluid?
If we apply a magnetic field to that fluid, its viscosity changes.
Its viscosity changes. How? Any idea?
Um,
Because we dealt related to the classification, gave one example also in the module 1. Now we will be going to study in depth related to it.
yes.
Okay, so basically the name itself will suggest what you mean by magnetorheological fluid. So in this, in short, it is called as MR fluid, and it is one of the class of the smart material. Since it is a fluid, instead of calling as a smart material, you call this as a type of a smart fluid. Okay, so whether it is a smart material or a smart fluid, it will responds to the external stimuli and give to the changes as per the requirement. Similarly here, the main property of this MR fluid is you can change the properties of an MR fluid by the application of magnetic field. So as we were doing it in case of piezo, we used to apply the electric field, right? Similarly, in case of shape memory alloy, you used to apply the temperature. So you used to heat up so that it changes, it reaches austenite phase. From then, when you cool down, it comes back to the martensite phase. Similarly, in this case, the main input what we will be subjecting here to the MR fluid is nothing but our magnetic field. So when you supply some magnetic fluid into it for an MR fluid, it apparently helps us to increase or enhance the viscosity aspect of it, right? So the fluid will become thicker and thicker so that the viscousness of that particular fluid will increase. And hence this type of fluid also have a particular type of applications where it could be used. So you'll be using this MR fluid usually where in you need an high viscosity. Okay, for particular applications, we go with that related to in future slides. So basically, when you call an MR fluid, it is nothing but magnetorheological fluid. It is a classification of the smart fluid whose properties can be changed by or when it is subjected to a magnetic field. So when it is subjected to the magnetic field, only the property which gets changed is related to its viscousness. So viscosity increases apparently. So this is the main thing what you have to understand, right? When you speak about the word MR fluid. So here you can see in MR fluid, there will be n number of molecules which will be arranged. So when it is subjected to a magnetic field, this is the direction in which the magnetic field is arranged. So that the molecules which were arranged in a random will be piled up in a sequential order. So at this region, since due to the accumulation of all the molecules very tightly packed within the given compact area, the viscousness of that fluid will increase. Okay, that is due to the direction of magnetic field. When you remove the magnetic field, again the viscosity of that fluid drops down. Sometimes it will be having some property to retain the viscousness for some period of time, not for a long period of time. So after that, again the viscosity of the fluid which was there before, the same thing will come back. So this is about the nature of magnetorheological fluid. In short, it is called as our MR fluid. So here you can just understand how the working principle of an MR fluid happens. Okay, so here you can see that it is an oil. So you might be having a bottom and a top plate, right? So in between you have an oil which has been passing through. So within the oil, the oil is embedded with some magnetic particles here. Means you are using magnetic particles as an additive to the oil, right? So this acts as an carrier and it provides some activeness in the smart fluid. You have studied the smart materials which are active and which are passive, right? So which are active are used as actuators, which are passive are used as sensors, that you have studied in the first module. Similarly, when it comes to the class of MR fluid, So you'll be using a particular oil. So in order to make this oil an active smart fluid, you need to use some carrier particles. So this carrier particle will be nothing but our magnetic particles, which will be embedded as a dopant or an additive, which makes the smart fluid active, right? So this will be mixed or reinforced or embedded with some magnetic particles, right? And the magnetic particles what you use should not be of very larger size. Okay, so the size should be either in the micro or nanometer scale. This micro or nanometer scale particles will not be visible to your human eye, right? But you have to crush and make the powder of the magnetic particles in such a way that it is either in the micrometer or in the nano scale. So this size of the magnetic particle will be applied into the oil what you are using. Okay, so this is done. So now you have the bottom plate and the top plate, and you have an oil in which you are supposed to use, and you have now embedded that oil with that of the magnetic particles. So when you subject the given working media or fluid to a magnetic flux, so what happens? It results in the alignment of magnetic particles across a particular line in sequential order. So this alignment takes place in the direction where the magnetic flux is applied or the magnetic field is applied. So based on the direction in which the magnetic field is applied, these particles gets accumulated like a streamline one above the other, right? So this is how it gets accumulated. So due to the accumulation of these particles, right, it results in increasing the viscosity of the material. So due to this flux, the viscosity of this MR fluid get increased and helps to reduce the shock. Okay, so this act is basically called as Bingham plastic. Okay, later you have to study some Bingham plastic models also, that we will be dealing little bit later. So first you should now understand how the working principle of an MR fluid takes place. Hope the working principle is clear to you people. Any doubts on this?
No, no.
Can I proceed further?
Yes.
Okay. So this principle is also called as Bingham plastic. So further, you should be knowing how the flow modes are in a given MR fluid. I told fluid means it won't be held stationary, it will be moving, right? So when it comes to a smart fluid, it has to be active. So it cannot be called that it will be stationary. I think someone's mic is not muted. Sandesh, yeah, thank
Sorry.
you. Yeah. So now it is upon the type of the flow of the modes you get in an MR fluid. So depending upon the fluid flow and the amount of stress which has been induced, there are three modes of MR fluid operations. So one is the valve mode, the second is the shear mode, and the third one is the squeeze mode. So you have to understand all the three types of flow modes which come across in an MR fluid. So now you know what do you mean by an MR fluid, what is the working principle of it, and now you have to understand how the flow mode will be there in a given MR fluid, right? So based on that, we are first starting up with the first flow mode, which is nothing but our valve mode. So what happens here in valve mode basically? So you can see here, so this is the stationary plate. Both the plates what I explained you in the beginning, the bottom and the top, both will be held stationary. It will not be moving at any case. Okay, so the bottom plate will also be stationary as it has been shown here, and the top plate also will be stationary. And the yellow color here which has been visible is nothing but our MR fluid, right? So this fluid will flow only due to subjection of the external pressure. So without the application of the pressure, you cannot make the fluid to move. right? So the same funda of fluid mechanics. So if you want to make the fluid to move, you should have some external force or the pressure which makes the fluid to move, or else the fluid will be in static condition. With respect to that, you have studied the statics and the fluid and the dynamic part of the fluid, right? Similarly here, the same thing, only thing is you are using magnetorheological fluid here. So when you apply an external pressure, it makes the fluid to flow on. So this is the direction in which the fluid flows. And always the direction of the magnetic flux in which we do apply will be exactly normal to the direction of the pressure which has been induced. Okay, so this is how the direction will be, right? The direction of the pressure here is towards our positive x, and the direction of the magnetic flux is exactly normal to it, right, which is moving towards our positive y-axis. And in between the two plates, we will be having the MR fluid, and both the plates here will be held stationary. It won't move at any cost. Okay, so this is the arrangement what you have to understand. And now we come for the valve mode. So I told you about three modes. Out of the three modes of the flow related to MR fluid, valve mode is the most commonly used type of flow, right? So here what happens is, here the two reservoirs of MR fluid are used. Basically, okay, the two reservoirs of MR fluid will be used, and the magnetic field is used to impede the flow of MR fluid from one reservoir to another. So what happens is, you'll be having a bottom plate and a top plate, and you'll be having two reservoirs of MR fluid in between. So when you apply the magnetic, you'll be having one reservoir of the MR fluid and one more reservoir of the MR fluid. So when you apply the magnetic field, what happens is, it helps this flux used will help the fluid to move from one reservoir to that of the other reservoir. It is nothing but like a thermal system where you have an if you have studied the applied thermodynamics and basic thermodynamics, so you'll be having the reservoirs bottom and the top, right? So it helps the heat what you subject will help to move the heat from the lower temperature system to that of the higher temperature system. Similarly here, the same concept, instead of applying the effect what we apply towards positive y direction is nothing but our heat or the temperature. Similarly here, in case of MR fluid, you will be using as a bottom reservoir and a top reservoir, and you will be subjecting that to the magnetic flux. Due to subjection of the magnetic flux, it helps the fluid to move from one reservoir to that of the another, right? So here usually the flow is achieved due to the drop in the pressure. So this drop in the pressure will be between the reservoirs. The bottom reservoir might be having some pressure, and the top reservoir might be having a low pressure, and the bottom reservoir might be having a high pressure. So when you apply the magnetic field due to the drop in the pressure between the two reservoirs, it helps the fluid to move in. Okay, or else it is really difficult to make the fluid to flow from bottom to that of the top. So where there is a difference in the pressure, or where there is a difference in the electric potential, in that direction usually the flow takes place. Or even the water, for the example, from high reservoir to low reservoir, it will easily flow down, but the reverse is not possible so easily. So to get the reverse flow from low reservoir to high, you need some external support, a back end. So that sometimes we use pump. So pump will provide you the energy which is needed to uplift the water from the lower reservoir to that of the higher reservoir. So that is a reverse direction. In a reverse direction, you need to make any fluid to move in, there should be some external pressure and a back end thing to lift the water from the low reservoir to that of higher. Similarly here, in this case, the drop in the pressure will help the fluid to move from the lower reservoir to that of the higher reservoir with the help of the magnetic field. So here the flow is basically achieved due to the pressure drop between the reservoirs, and the flow resistance is controlled by the magnetic flux what you are applying. So here you will be using some valve mode and an operational mode. So these are nothing but the dampers as well as the shock absorbers. because you'll be having one bottom reservoir, one top reservoir. This is just to make you understand the concept of valve mode, how it will be. But in actual, you might be having one bottom reservoir, a top reservoir, right? So here you'll be having the bottom stationary plate, the top stationary plate. So this will be the pressure through which it is will be passing on through the MR fluid. And due to the drop in the pressure between the top and the bottom reservoir, it helps the fluid to move in the upward direction. So to move in upward direction, you need something. So we are applying the magnetic field. So due to the applied magnetic flux, it helps in uplifting the water from the bottom reservoir to that of top. So to make this fluid move from bottom to the top, you need some valves. It has to open and close, right? So these are nothing but the valve mode and the operational mode. So across the valve mode, you will be having the dampers, and across the operational mode, you will be having the shock absorbers. So this is the main thing what you will be having in case of an valve mode. So you will better understand when I speak about a particular application related to the valve mode. Everyone have heard about the word shock absorbers, right? So here you are just seeing a diagram of an shock absorber. So this is in aeroplane, basically you use the shock absorbers in order to reduce the amount of vibration. So the vibration damping wherever it is very high, if you use the shock absorbers, it will be able to absorb the vibrations and makes the things to be very smooth. So while landing in an aircraft or aeroplane, right? So vibration should not be so much high that it will hamper the ears of the passengers who are sitting within the plane, right? Even though it has vibration control also, sometimes the people will get ear pain, right? So usually they give the cotton buds so that it won't affect your eardrums. Some people will get pain in the ear due to this effect. So in order to overcome all these obligations, usually vibration damping has been used. So for that, we usually use shock absorbers. So if in case in shock absorbers, if you are using MR fluid, right? So this will basically having a tendency for high damping absorption behavior. So this is the application of MR fluid where you need in case of valve mode mechanism. So here you can see that, right? So this is a place where you will be using the MR fluid, so which will be acting as an absorbent foam, right? So you will be having, this is a shock absorber, so where you will be having an plastic shaft here, right? So these are the electrical leads which provides the required input. So you'll be having the steel tube here. This is the main steel core, and you'll be having the coil. So the vibrations which is coming has to be reduced. For that, you should be having some material which absorbs the vibration, right? So to absorb this vibration, you should be having some material which is capable of energy absorbent behavior. Usually many of the composite material have energy absorbing capability, right? It could be an viscoelastic foam, yeah, rigid foam, yeah, semi-rigid foam, whatsoever, but that is often solid particles. So that foam cannot be embedded here in a small area where only a passage of fluid could be moved in. So in that case, where you cannot use a composite material to reduce the damping behavior, you need something in the fluid form which has the same capability to absorb the vibration. So in that mode, if you use this MR fluids, this will be having a very good uh, what we say a very good application in absorbing the vibrations which is coming out when a plane is been moving, right? So this helps in absorbing the vibrations, and it reduces the vibration, and the customers within the plane will not realize any sound as in when it is coming to landing. Okay, so this is the main application of our MR fluid, and this is an example for our valve mode mechanism. So first one we have dealt about. So next is the shear mode. Is the valve mode clear? Any doubts in it?
No.
Okay, so next we are going for the shear mode. So what do you mean by shear? Anyone can let me know? You know what do you mean by stress? You know what do you mean by strain? What is shear force? Anyone can tell me? So related to the shear force, you have the shear mode here. So if you understand the concept of shear, you can tell me exactly how the operation will be. Anyone can let me know what do you mean by shear force? Only the difference is in the previous valve mode, we were subjecting pressure here. So instead of pressure, you are now subjecting some amount of force, right, in terms of newtons. So how the shear comes into picture here? Can anyone let me know? Mohanambal, you are there? Good morning.
Good morning.
Yeah, what do you mean by shear? Shear force?
Mm, Two opposite, equal and opposite force acting.
Equal and opposite force acting, then shear will come into picture, is it? Can you relate that to the shear mode here? What do you understand? Previously, valve mode have explained you, right? You will be applying the pressure. Due to the pressure, the MR fluid will flow. You will be having a bottom reservoir and a top reservoir. So the drop in the pressure will help the fluid to move in the direction where you are applying the magnetic field. So this was the funda behind the valve mode. So now the same concept is with respect to the shear mode, where you'll be subjecting the where you'll be giving the input as a force. Due to the applied force, the fluid will move with some particular speed. Apart from that, remember here you have a stationary plate and a movable plate. Then only shear can come into picture. If two plates are stationary, you cannot get the required shear mode. I'm giving you so much of hint. Can you now just explain me what exactly happens in case of shear mode? Yes, please continue. What happens basically? Everything is in front of you. The diagram is there. The concept I've explained you. Only thing you have to help me in telling how the shear is coming over here. That's it.
Due to the force acting, the plate moves.
Hmm. See, only the top plate will be moving here. The bottom plate here will be held stationary. So the fluid at the bottom layer will be stationary, and here above it will be moving. And in that place, how the shear comes into picture, only that concept you let me know. Be quick. You have studied this already.
Shear strain, gets shear strain along that direction.
What? Louder, louder.
Due to the shear force, there'll be strain acting. Shear strain will act in the direction.
No, to get shear, both should be moving in some opposite direction, right? So
If
this is the direction in which you're getting the force. Yeah, tell me now. It is used in brakes and clutches. How do you apply force on brake and clutches? How does it operate? You ride a vehicle?
Yeah, ma'am.
Yeah, take an example of it and let me know. You will be have the vehicle will be moving in a particular direction. You suddenly apply brake, then the vehicle stops. Why it gets stops? Can you let me know? Due to what reason?
Mm,
Why when you apply brake, the vehicle gets stopped? It could be either a two-wheeler or a four-wheeler, anything you have used.
There will be no friction.
Yes,
There will be no
there will be
friction.
no
Friction, ma'am.
due there'll be no friction, for that the vehicle gets stopped, is it? Sandesh, is it right?
Due to friction.
Huh?
Due to friction, ma'am.
Due to friction. Whether the friction will be there or not there. If there is no friction, the vehicle gets stopped.
It will be there, ma'am.
No, it will.
It will be.
There, ma'am. Friction will be there.
So now, what do you mean by shear then? Come back to this diagram. One, you have a moving plate, another one you will be having a stationary plate. You will apply the force. Due to the force, the MR fluid will move in the direction in which the force is applied, right? So along with that, you have a magnetic flux which is acting in the direction normal to the applied force. So due to the moving plate and one fixed plane, how will be the flowing condition of the MR fluid, right? So here the plate is moving, and the fluid also has to move in the same direction, or it will be moving in the opposite direction, because one plate is stationary here.
It will make the one plate to slide over the
Huh?
other. It will make the one plate slide over the
Louder.
other plate.
What happens basically is this plate is stationary and this is movable. Due to the force, it makes the plate to slide here. Okay, so it is not like the fluid is moving. You are applying the force on this moving plate. So this plate will get smoothed, and initially this fluid will be held stationary. This fluid will be held stationary and this is sliding. So due to this sliding, some amount of layer across the top, right? So due to this moving, the shear will come into picture, because when a fluid you have across a plate which is moving, it will be also having the tendency to move in, right? So due to this movement, it results in the formation of the shear. And with that shear force, you have a magnetic field which is subjected in the direction normal to the force which is applied to the moving plate. And as a result, what happens is it again results in the alignment of the magnetic particles across the direction in which the magnetic field is. And hence, then the viscosity of the MR fluid will increase. So this is the mode which helps the MR fluid to move due to the shear. The previous one was you was directly applying the pressure to the MR fluid. So this fluid used to flow here and the plates were held stationary. But now you have the tendency for the fluid to move due to the movable plate, wherein one is stationary. So it can move in this direction slightly, whereas the lower layer of the fluid will be held stationary. Due to the partial movement of the fluid and the bottom layer in the same position, right? So it results in causing some amount of shear. So with respect to that shear and the magnetic field applied, you will be having the alignment of the particles, magnetic particles, in proper sequential order. So this helps in resulting the viscosity of the MR fluid, and it gets removed out when you remove the force subjected to the movable plate. But still, some of the MR fluid will be having the tendency to retain the viscousness in it for some extent. After that, it will be not able to get the high viscosity in it. So this is the main difference between the valve mode and the shear mode. In valve mode, you will apply the pressure to the fluid, and you will be having the valves which gets opened from lower reservoir to upper to the higher reservoir, which are nothing but the dampers and shock absorbers. Whereas in case of shear mode, you will apply the force to the movable plate. This will be moving and the fluid will be stationary in the bottom. Only the top layer, which is across the movable plate, will be moving. Due to this, the shear comes into picture, and the alignment of the particle across the magnetic field will provide you the required viscousness. Now hope that it is clear, the shear mode.
Yes, ma'am.
Yeah. So we need to discuss some features of the shear mode here. So shear mode, it differs in operation from squeeze mode. Squeeze mode is nothing but our third mode, right? So it is different from squeeze mode. Why it is different, that you have to understand. Due to moving paramagnetic sliding or rotating force. In case of shear mode, you just have a sliding motion because the plate is been moving at the topper layer. It is not rotating as such. In case of squeezing, you have some other mechanism which helps in twisting also. So that is the difference in case of shear and squeeze mode. And in shear mode, basically it has a thin layer of MR fluid which is sandwiched between paramagnetic surfaces. So here you'll be having a thin film of MR fluid, and this will be sandwiched between paramagnetic surface. So you'll be having one paramagnetic surface over here, another paramagnetic surface over here, and a thin layer of the fluid. So that helps in getting the required effectiveness, okay, for the shear mode. This is one thing. So mainly what happens is in shear mode, it is different from squeeze mode because you don't have any rotating or twisting effect which comes in squeeze mode. But in case of shear mode, you will be having a very thin layer of MR fluid which is sandwiched between the paramagnetic surface, because you should have a magnetic effect to the MR fluid. In case of valve mode, you used to embed the particles within the fluid. But whereas in case of shear mode, you will be having two surfaces, one at the top and the bottom, which are nothing but paramagnetic surfaces. Mean to say the surface is made up of paramagnetic materials. So these are the thumb rules what you have to consider in case of shear mode and how it is different from that of our squeeze mode. And as usual, even in shear mode, the magnetic field will be perpendicular to the direction of the motion of the given moving surface. So the moving surface. In case of valve mode, the difference was, if we go back to valve mode here, the magnetic field was acting in the direction normal to the flow of the fluid. Only difference here now is the magnetic field what you apply in shear force, shear mode, will be normal to the direction of the moving plate. Instead of fluid, you will be telling as a moving plate because the plate will be moving here rather than that of the fluid. Only the top surface of the fluid, which is associated with the movable plate, will be having some slight movement. So this is the second thing which is being told here. The magnetic field is perpendicular to the direction of the motion of the moving surface. So example where you use shear modes basically are in clutches, brakes, in locking device, and sometimes even it is being used in some of the structural composite materials. And always this shear mode type of devices of MR fluid is basically suitable for small force applications because you cannot subject a high amount of force on a moving plate. The moving plate will be not so strong enough to bear the force which has been subjected for heavy type of loading, right? So you can use this type of device of MR fluid wherein the force subjected is of an minor one or a small amount of force. So it has some restrictions. So the shear mode cannot be used for high force applications, right? Only where the minimum or small amount of force you can apply, in that you can go for the shear mode devices made up of MR fluid. So these are the features of shear mode. So if they ask you to explain the modes of MR fluid, you should right away start from the flow modes. You should tell all the three types of modes. You should explain what is valve mode, draw the diagram, just justify with one application for it, then come for shear mode, tell how, draw the diagram, how does it operates, its features, right? And you can associate that with a application. So here braking system is an application for a MR fluid under shear mode. So you can see that again here you'll be using in this area our MR fluid system, which mainly helps in subjecting the speed control by using our brake system. So if you use a MR fluid here, you will be having a coil. So when you press, so it will apply some force on this MR fluid. So that helps in getting the required amount of brake in an media which you are using it. So you basically you will be having an rotor here. So this is the shaft, right? So this is the housing for the entire device. So in order to make this MR fluid as an braking system, you should be having some magnetic field, right? So the magnetic field here will be associated at the bottom as well as the top. So you'll be having the coil here. So when the force has been applied on the coil, so when you apply the force on this coil, what happens that the force which is required for the MR fluid here will be received. So based on the flow, based on the force applied on this moving plate, the shear comes into picture, and due to the shear and subjecting magnetic field, the magnetic field here is being subjected in the opposite direction, in the normal direction, right? The brakes will be applied and the vehicle gets stopped. So this is how even you can use the MR fluid in braking system. So in latest technologies, they are using even MR fluid to get a sudden brake in an vehicle which is moving even in a higher speed, right? Mainly it depends upon which type of MR fluid you are using and the quality of the magnetic fields. So whenever the person applies the brake on the coil, the force is subjected to the MR fluid, right? Due to, and this plate will be held movable due to the applied force, but the fluid inside will be held stationary, right? So due to that shear which is subjected in the MR fluid and subjection of the magnetic field in the direction normal to the flow of plate, it will result in making the vehicle to stop. So this is an example for braking system by using MR fluid. Is this clear? Hello?
Yes, ma'am.
Yeah. So, yeah. So next you have to understand some of the mechanism and properties associated with ER and MR fluids. So that I will carry on in the 4th hour class today. And this is one of the real-time application. So where this type of MR dampers could be used. So sometimes a person will not be having leg, so they make an artificial leg and get embedded here, right? So it will be a painful thing where the person has to use an artificial leg for a longer time. Usually it will be made up of some wood or some other hard steel material, so which will affect the knee joint very badly. So if you make some lightweight material for the leg structure, and if you use the damper here made up of MR, so that helps in reducing the jerks or the vibrations which come in when a person walks using an artificial leg. Because what happens is a human leg has a capability to withstand any amount of stress, yeah, strain when he walks or when he runs. But the same thing cannot be possible by using an artificial leg, because when he starts moving, the parts, the mechanism which is jointed here results in making noise, vibrations, right? So if he walks very slowly, then no vibrations will be there. But if he walks very speedily, or sometimes he need to run, it is very difficult. When you have a thigh portion here, the leg portion, this has to be connected here in the form of a knee joint here, right? So you should be having a proper motor. So motor has to run properly, and you have a hinge here. So due to this movement, n number of vibrations will be resulted, noise, and moving particles makes noise. So to reduce all these and to get a very smooth flow of walking, you should be having some dampers. So if you make use of a damper of this MR fluid, right? So it really helps a person's life to be comfortable with lightweight material, with required smooth flow of walking and running, with reduced amount of noise in the mechanism due to connection of the thigh to the motor, and from there to the leg. Again, that has to be connected artificially to an foot also. So many movements with so many constraints. A leg can bend, can rotate in any direction without any noise. But if you want to do that with an artificial leg, it obviously creates sounds, right? That is made by man and not by God, right? So to overcome that amount of vibrations, you need some damper in it, where you cannot use a composite material basically. So it will be a small layer in which you need to put a small amount of fluid. So in that place, if you add in this MR fluid, it helps to absorb the vibration and provide a required smooth flow of the leg as per the requirement. So this is how and real-time application could be used for our MR fluid. So in the fourth hour, we will be dealing with the mechanism and properties related to ER and MR fluids. So now I hope you people have submitted the assignments. Anyone who haven't submitted the assignments here?
Submitted.
All have submitted?
Oh no.
Okay. So now answer your roll call. I will put you a quiz question later after the 4th hour class. Danush is there? Danush is not still feeling well?
No.
He has posted a message that he was not feeling well in the last class also. Mithun? Mohan Ambal?
Yes, ma'am.
Sandesh?
Yes, ma'am.
Srinidhi? Sukrut?
Yes, ma'am.
Vinay D is not attending any class in any other subjects also.
No.
Any reason, have you contacted him?
He's not even attending the classes, and sir told he won't come.
He won't. Okay. Okay. And Sri Harsha?
Yes, ma'am.
Sri Harsha? Yeah.
Yes, ma'am.
Yeah. So everyone type your name and USN number in the chat room. Those who haven't written, Sandesh has written Mohan Ambal, Harsha. Others?
Ma'am, it's coming failed to send, ma'am.
It is coming?
Failed to send.
Failed to send.
Yes, ma'am.
Okay, you just tell me your USN number to me. Sukrut, right?
Yes, ma'am. 1BY 19 MMD 06, ma'am.
1BY 19 MMD
06.
06. Okay. Okay, then take care. We'll meet you again later. Have a good day. Bye-bye.
Thank you.
Yeah, bye-bye.
Thank you.
Yeah.